Hey, this is Derek Whatley. I'm an engineer working on the OpenShift migrations team at Red Hat. In this video, I'll be introducing some of the migration speed enhancements slated for the Crane 1.5.0 release. We've added a feature flag in Crane 1.5.0 that allows you to turn on cached clients. The main impact of this is increasing migration speed significantly. Here we can see one of the impacts of turning cached clients back on. The PV discovery process, which you go through every time you create a migration plan, takes far less time, in this case 354 milliseconds compared to 10 seconds originally, or 28 times faster. PV discovery is a little bit of an outlier because it's doing mainly read operations. But in this case, let's take a look at a demo where we do a mix of read and writes, and we're communicating with clusters that are about 22 milliseconds network latency away. So we're going to migrate Rocket Chat from OCP 3.11 to OCP 4.6. So in this demo, you can see these two clusters side by side performing the same migration. And immediately we notice that the controller that's using a cache has flown through the first few steps of the migration and is already running the rsync as part of the direct volume migration. The prepare step and several other parts of the migration that do a lot of reads take a lot more time when you don't have a cache in the system. Still, the elements of the migration that are delegated out to other systems like Valero or the direct volume rsync are still going to take a little bit of time because there's no way to speed those up with a cache. The PV data still has to be rsynced from one cluster to the other, and we still have to let Valero do a copy of all the resources. However, we can see that with a cache, our migration completed in 82 seconds, a bit over a minute, and when we compare this to the controller that's running without a cache, there's a big difference. So we can see that one is still performing its rsync, it's still doing its final Valero restore. So we've beat it by a significant margin. And in this case, it's actually more than twice as fast. The cacherless controller finishes at 198 seconds versus 82 seconds with the cache. Apart from the improvements in migration speed that we see, reduction of load on the API server is another big benefit you get from enabling cached clients in MIG controller. So this will allow your API server to have to serve less read requests. When we were evaluating the usefulness of turning the cached client back on for MIG controller, we looked at the metrics and we saw that when you compare the number of read calls against the API server, that is the list and get calls, compared to the create, update, delete, write calls, there were 593 reads and 38 writes during a Rocket Chat migration. And this indicated to us that our controller is very read heavy and we should optimize for that. One thing to be aware of if you're going to enable the cached client with your controller is that this will increase memory consumption. This is going to be caching the Kubernetes resources that the controller interacts with. So you'll need to be mindful, and if you see out of memory killed errors on the controller, you'll need to increase the memory limit. One other thing to consider is that the cache that we're using, which is based off controller runtime's cached client, has a problem of sometimes becoming stale and containing data that's out of date. This is actually by design, and controller runtime does this knowingly, but in our case, this would have introduced a lot of required refactoring, so we implemented a workaround of sorts where we poll for the element that we've just written to the API server to be present in the cache before continuing. And in our case, this seems to work quite well. I think because of the mixture of read and write calls that we perform, there's not a lot of performance penalty given that we perform mostly reads against the API server and just a few writes. So this is a simple diagram showing the flow that we've implemented where anytime there's a write to the API server, either a create or an update, we poll until the cache populates with the new resource version and then we return the result to the caller. This is transparent to you as the user, and if you want to try this out, if you want to see these performance gains for yourself and you have the memory to spare, you can run this command in Crane or MTC 1.5.0 and you can see the effects of the cache.